All right. This time we're going to look at some IRT model graphs for some items in our measurement. So yeah, this one's going to be kind of interesting. Most of the code is on an exploratory factor analysis so that we can demonstrate unit dimensionality in our construct, because without unit dimensionality, IRT plots don't really mean anything. But yeah, then we're going to look at some of these plots, and it's gonna kind of talk in IRT terms. So we're going to be looking at A parameters, which is discrimination, and B parameters, which is difficulty of the items that we're including in this analysis. Introduction to the data set. We're going to be using the data set that we've been using for these past couple of assignments. I'm going to go ahead and run all of these top ones. We got a few libraries that we're going to have to use later on, particularly right here. And then we got our read Excel, just trusty, handy read Excel. So I'm going to push everything into this EFA data. It's called EFA data mostly, so I didn't have to change anything regarding the EFA syntax that I have, because as we're going to see a little bit later, some of the assumptions of EFA aren't readily available in R, so we're going to make our own function. But so I didn't have to change anything there. I just called it EFA data. Seemed like a reasonable name for it. Anyway, so let's go ahead and run these highlighted rows 1 through 10 lines. Boom. Okay, so now we have our EFA data up here. We've got almost 400 observations, 399, with 19 variables. And so the first thing we're going to want to do is kind of call this data set down, because we only want one of our subdimensions on here. By this point, we're familiar with the D, J, P, J, I, E, J. So what did I look at? We're just going to look at the IJ dimension. And we're just going to look at 1 through 4, since that's the minimum we need to. And if we looked at more items, we'd have more graphs. So just for the simplicity of demonstration, we're only going to look at 4 items. So in order to do that, to take these out, I don't actually have to make a new data set. I can just take them out of the data set that I have. So I'm going to run a bunch of these null commands that are going to basically delete all of these variables that I don't want. So I have a line for each one, and then I have the exclamation here, but you can just see that the variables I had, the ones I don't want, just going to take them each out individually. Oops, I ran that twice on accident. Doesn't really matter though, because it can't take away what's already gone. And bam, there we are. We only have the 4 IJ items that like we wanted. There's plenty of different ways you could do this. You could have already manually manipulated your data set to only have the items that you wanted, which is kind of how we did things traditionally. But basically, so that as long as you end up with a data set that only has the items you're interested in, you're good to go. That's just how I chose to demonstrate it here. And then I have this line, which is kind of, honestly, should probably just be at the end, but we're going to go ahead and run it. All this is doing is making a copy of my data set that's called IRT data, because, like I said before, we're going to be doing some EFA stuff and then some IRT stuff, and it gets kind of confusing just using EFA data in the IRT context. So I just wanted to make a copy so that the code looks a little bit, it makes more sense in the context of the syntax. So yeah, let's get into the EFA stuff. And before we're going to want to run our actual EFA, we're going to want to test some assumptions. So we're going to test 3 assumptions here. The first is, well, first we're going to make a correlation matrix that's going to get pushed into this EFA matrix variable. Let's go ahead and do that. Run. Boom, EFA matrix. Yeah, just a correlation matrix, pretty standard stuff. There we go. Yeah, it pops up in this tab. So I was clicking a bunch of stuff I shouldn't have clicked, but to get back over, we're going to just tab back on over. Okay, cool. Next we're actually gonna test the assumptions of EFA now. So the reason we're doing that, like any assumptions, is because if we aren't meeting the assumptions of our test, and then the results that we get from the test don't actually mean anything. And since we want to use EFA to determine unit dimensionality in our data so that we can confidently use it and interpret our IRT metrics, we want our EFA to actually mean something. So we're going to test the assumptions. I guess I could talk about unit dimensionality for a little bit. Basically, what that means is that all the items that we're looking at are actually measuring the same thing, pretty much. And we already have an idea that these are going to be doing that because EFA and CFA have already been conducted for them. But just presumably we didn't know that we're going to run an EFA just to make sure, and we're only using 4, so let's just make sure that things didn't change. Anyway, first assumption that we're going to test is our correlation matrix different than 0? It's basically it's the Bartlett test, a test against the null, the identity matrix. So this test should be significant. If it is significant, that means our matrix is not statistically significantly different from 0. So let's run that. We get our first output into the console, p-value of really small. So that is a significant test. Good, that's what we wanted. Next assumption is going to be the KMO function, which we use to look at covariance. The data has to reach a certain level of covariance to be acceptable for to run an EFA on. So I have this collapsed right now, but these lines 48 through 95 are the syntax that I got to make this KMO test function, KMO function. So what this is all doing is creating a KMO function that we can use to test KMO. So all these comments and stuff in here I did not write. I pilfered that off the internet, just like you might download a package off the internet. And so I have that written here. If you want to check out that website, I listed it here in this comment. Just go ahead and copy and paste that. Shout outs to them for providing that. But basically, so 48 through 95 is making this function KMO, which we're going to utilize in 98. Let's go ahead and run that. Huh, cool. We got an error. And that's easily explained because we haven't created our function yet. How could we possibly use a function we haven't created? So I'm going to go ahead and run that data, or run that syntax that I said that I pilfered off of the internet, so that we actually have a function to use. Boom. Now we have this KMO function. Cool. Go away. Now we can run the function now that it exists. And we're going to get a bunch of output that honestly I don't care about too much other than basically this and this. Basically, if you look inside of this, it's got a range of options that'll tell you how acceptable it is. This one in particular is a KMO in between 0.8 and 0.9, which is meritorious, which basically just says it's pretty good. It could be a little bit better, but you're good to go. It's just one step down, basically, will be super good. So that's a pass. If it did not pass, you would see some dialogue like this. Mediocre or miserable, and middling would also be questionable. So meritorious, though, we're good to go. We're at 9 minutes already. Okay, cool. I think we might actually be able to finish this. So, and the last thing we're going to do is check the determinant of the correlation matrix. That's checking for multicollinearity. And if it's like really low, then we might have a multicollinearity problem. So let's check it. It's not really low, and really low being, like I have commented here, less than 0.0001. It's not even close, really. So we're good. shouldn't have any multicollinearity problems. So we're finally going to be able to test run an EFA. Basically, what we're looking for in this EFA is that our data reasonably shows that there's only one factor being measured in our 4 items. Again, unidimensionality, 1 factor. So we're going to run it, and we're going to be looking for eigenvalues that are above 1 for 1 factor and not above 1 for any other factor. And then we're going to run a scree plot, and hopefully we can see that nice scree shape where it's pretty clear that 1 factor is a solid option, and then it's going to level off starting at 2. 2 would not be an option even. So yeah, let's run the EFA. I'm going to go ahead and run the EFA model line. R is just the matrix that we created earlier. That's what it's using to get its data. 4 factors because we only have 4 items. Really unlikely that we'd be assessing 5 factors with 4 items. No rotation and maximum likelihood method. I'm going to go ahead and run this 109 line 2 so that we can get some output. Boom. Factor loadings. Oh, wow. SS loadings 0, 0, 0, 2.2. So yeah, that's pretty good. Let's go ahead and look at this scree plot. This 113 line runs the scree plot basically. It's just looking at the eigenvalues from this output of the EFA model. Yep. Yep, that's a 1 up here, and that's nothing else down here. Perfect, exactly what we wanted to see. So our unidimensionality can be assumed. We're now at 12 minutes, and I have a feeling that I'm going to be making another video. That's okay, because we're going into actual IRT syntax now. Let's go ahead and get this LTM library so we can run our graded response model that's necessary to look at these IRT curves. Kabam, we're going to run this model. Like I just said, GRM stands for graded response model. Based on our IRT data, which remember is just a copy of our data set that we made up at the beginning. Boom. Now we have the model. Pretty uninterpretable, as we come to expect from R. We are going to rely on our console to provide us with the useful information by running this model line at 125. Cool. So this spits out pretty much some bare bones information. 3 difficulty parameters for each item, or sorry, for these XTRMTs are basically difficulty parameters. So 4 for each item, and then 1 discrimination value for each item. And you can see that visualized in these plots. And I have some comments here if you're interested in what these variables mean. They're not particularly important. Most of it is just formatting stuff. Let's go ahead and run this. This little thing is peculiar in that you run it once. So I just ran it, and then the console pops up here to click enter, well, return, which is enter, to get the actual value, the plot. So I'm going to click. And there's 1, and then it's like, do it again. It's going to do this 4 times because we have 4 items. So I'm going to click again, and click again, and now I have all 4. Cool. Yeah, now I have all 4. And you can view them like this. Do note that in order to get that all to work, you have to actually you have to have your clicker like being highlighted in this console. I'm going to go ahead and run it again because I'm going to have to make another video anyway and show you kind of more what I'm talking about. See how it's not highlighted in here? I'm highlighted in this this section, so if I click enter, I'm not going to get any plots. I have to come and click over the console and I start getting plots. Okay, cool. So I'm not going to make it in one video this time. I'm going to go ahead and clean this up, and I will be back to finish this off in just a bit.